Now we are going to venture into the modeling and subsequently the simulation of network layer of the TCP/IP stack. For that, a very appropriate starting point is to determine what kind of services are we expecting to be provided at the network layer, because after all, network layer is below the transport layer and it is going to provide services to the layer above it, that is the transport layer. Of course, the data link layer is below it, so network layer is going to draw services from the layer below. In this module, we shall look at the need and the types of various network services. Network layer is basically the workhorse. It is the carriage that transports data from the sender to the receiver and takes care of all the in-network functionality. The upper layer at the transport necessitates certain functionality respective to what exact kind of transport layer protocol is being used. For instance, if you are using TCP, it is already taking care of reliability. So do we need support for reliability at the network layer again? Well, that is the question which I leave to you. Likewise, if you are using UDP, a connectionless unreliable service, should it be based on another unreliable IP kind of service? Then who is going to take care of the retransmissions? That's another point for consideration. Then we could also have ATM, which in itself provides equivalent layers to the application layer in the form of ATM adaptation layer and transport layer and below in the form of ATM virtual circuits, virtual paths, and the ATM network, data link, and the physical layer. So, when we are trying to establish a relationship between the network layer of a certain scenario under consideration, should it be solely based on ATM, or do we need a mix of connectionless and connection oriented services at the network layer? It actually means that we are going to go deeper into the kinds of service models which are available. Services can be broadly categorized as for individual packets, such as IP datagrams, where each IP packet in itself carries source IP and destination IP addresses. What best we could provide at the network layer could be, we could ensure guaranteed delivery, or we could go a step ahead and we could give guaranteed delivery with some time bound. On the other hand, if we look at the services as a flow of datagrams, then we are going to look at the services from a different context, because each packet belonging to the flow has to be treated in a similar way. So the new set of requirements emerge, such as whatever packets belong to this flow must be delivered in order, whereas this requirement was not there when we were looking at the datagrams. Then guaranteed minimum bandwidth to the flow, because after all, this flow belongs to a sender destination pair and it is in competition with other transmissions. And jitter requirements also emerge, which have to be defined in order to restrict the maximum jitter that these flow packets have to experience. This all can be categorized in a tabular form given in here. I've taken the resources from Kuros and Ross. Here you can see that at the network layer, IP as the best effort service literally provides no services at all. For example, it does not provide any bandwidth guarantees, no commitments to retransmit in the wake of loss, no reordering of IP datagrams, and of course, no synchronization, delay, and jitter services. And it also does not provide any combat strategy to handle congestion. So, as we already know, TCP/IP is a successfully running protocol stack. So, who is taking care of all these things? It is the transport layer TCP. That is why On end to end, we are sure whatever would be lost shall be recovered. The only thing that IP does is, in a very transparent and beautiful way, it ensures the delivery using different routing and forwarding mechanisms. If we compare it to ATM, which is a virtual circuit based switching technology, it uses a broad range of services starting from constant bitrate, variable bitrate, available bitrate, and unspecified bitrate. If we start with the constant bitrate, of course the bandwidth stays constant and it provides guarantees for all, that is loss, order, and timing. However, it does not provide any congestion management strategy. If we move on to variable bitrate, it is a step ahead towards the better. Still, no congestion combat strategy is proposed. The available bitrate provides no minimum service. So, whatever is available, like best effort, shall be provided. So, you can say that available bitrate is kind of IP equivalent in the ATM world. And last but not the least, the unspecified bitrate. It provides literally no functionality except for ordering, because whatever is transmitted in ATM switches is transmitted as a flow, so ordering is still not an issue. With this, what we conclude is that the network services have to be carefully chosen, and we talk about modeling them. Our model should include only the relevant protocol that is going to serve our network design goals, and hence the subsequent simulation would also become easier.